So in July of 2016, Spark released Spark 2.0. And let's talk about what's new and what new capabilities exist in MLLib now. So the main thing with Spark 2.0 is that they're moving people more and more toward data frames and data sets. Data sets and data frames are kind of used interchangeably sometimes. Technically, a data frame is a data set of row objects. They're kind of like RDDs, but the only difference is that whereas an RDD just contains unstructured data, every row of an RDD can contain pretty much anything, a data set has a defined schema to it. So a data set knows ahead of time exactly what columns of information exist in each row of that little RDD, of that data set, and what types those are. So because it knows about the actual structure of that data set ahead of time, it can optimize things more efficiently. It also lets us think of the contents of this data set as a little mini database. Well, actually a very big database if it's on a cluster, right? And that means we can do things like issue SQL queries on it. So this creates a higher level API with which we can query and analyze large, massive data sets on a Spark cluster. So it's pretty cool stuff. It's faster, it has more opportunities for optimization, and it has a higher level API that's often easier to work with. Now going forward in Spark 2.0, MLLib is pushing data frames as its primary API. So this is kind of the way of the future here. So let's take a look at how it works. So I've gone ahead and opened up the Spark linear regression.py file. Let's walk through it a little bit here. So you see, for one thing, we're using ML instead of MLLib, and that's the new data frame based APIs in there. So in this example, what we're going to do is implement linear regression. And linear regression is just a way of fitting a line to a set of data. So what we're going to do in this exercise is take a bunch of fabricated data that we have in 2 dimensions and try to fit a line to it with a linear model. And what we're going to do is actually separate our data into 2 sets, one for building the model and one for evaluating the model, and we'll compare how well this linear model does to actually predicting real values. So to do that, first of all, in Spark 2, if you're going to be doing stuff with the Spark SQL interface and using data sets, you're going to be using a Spark session object instead of a Spark context. So to set one up, you do something like this. You can say Spark, that's going to be the name of our Spark session, builder config. Now this bit is only necessary on Windows and in Spark 2.0. Kind of works around a little bug that they have, to be honest. So if you're on Windows, make sure you have a C temp folder if you want to run this. Go create that now if you need to. If you're not on Windows, you can delete that whole bit here that I've highlighted, okay? Because it's not going to be necessary and it won't work. Give it an app name and get or create. Now this is interesting because once you've created a Spark session, if it terminates unexpectedly, it can actually recover from that the next time that you run it. So if we have a checkpoint directory, you can actually restart where it left off using get or create. All right, now we're going to use this regression.txt file that I've included with the course materials, and all that is a text file that has comma-delimited values of 2 columns, and they're just 2 columns of more or less randomly, linearly correlated data, and it can represent whatever you want. Let's imagine that it represents heights and weights, for example. So the first column might represent heights, the second column might represent weights. So in the lingo of machine learning, we talk about labels and features, where labels are usually the thing that you're trying to predict, and features are a set of known attributes of the data that you use to make a prediction from. So in this example, maybe heights are the labels and the features are the weights. Maybe we're trying to predict heights based on your weight. It can be anything. It doesn't matter. This is all normalized down to like data between -1 and 1, so there's no real meaning to the scale of the data anywhere. You can pretend it means anything you want, really. So to do this, to use this with MLLib, we need to transform our data into the format it expects. So the first thing we're going to do is split that data up with this map function that just splits each line into 2 distinct values in a list. And then we're going to map that to the format that MLLib expects. So that's going to be a floating point label and then a dense vector of the feature data. Now in this case, we only have 1 bit of feature data, the weight. So we have a vector that just has 1 thing in it. But even if it's just 1 thing, the MLLib linear regression model requires a dense vector there. Okay, this is like a labeled point in the older API, but we have to kind of do it the hard way here. Now next we need to actually assign names to those columns. So here's the syntax for doing that. We're going to tell MLLib that these 2 columns in my resulting RDD here actually correspond to the label and the features. And then I can convert that RDD to a data frame object. So at this point I have an actual data frame, or if you will, a data set that contains 2 columns, label and features, where the label is a floating point height and the features column is a dense vector of floating point weights. And that is the format required by MLLib. And MLLib can be pretty picky about this stuff, so it's important that you pay attention to these formats. All right, now like I said, we're going to split our data in half. So we're going to do a 50-50 split between training data and test data. So this returns back two data frames, one that I'm going to use to actually create my model and one that I'm going to use to evaluate my model. I will next create my actual linear regression model with a few standard parameters here that I've set. We're going to call that LUR, linear regression. And then I will fit that model to the set of data that I held aside for training, the training data frame. And that gives me back a model that I can use to make predictions from. So let's go ahead and do that. I will call model.transform.test with testdf. And what that's going to do is predict the heights based on the weights in my testing data. Okay, so the testing data set, I actually have the known labels, the actual correct heights, and this is going to add a new column to that data frame called predictions that has the predicted values based on that linear model. Now I'm going to do a couple of things with this, so I'm going to cache the results, and now I can just extract them and compare them together. So let's pull out the prediction column just using .select, just like you would in SQL, and then I'm going to actually transform that data frame and pull out the RDD from it and use that to map it to just a plain old RDD full of floating point heights and floating point heights in this case, right? So these are the predicted heights, and then we're going to get to the actual heights from the label column, and then we can zip them back together and just print them out side by side and see how well it does. Now, mind you, this is kind of a convoluted way of doing it. I did this to be more consistent with the previous example, but a simpler approach would be to just actually select prediction and label together into a single RDD that maps out those two columns together, and then I don't have to zip them up. But either way works. So let's see if it works. So to run this, again, we'll open up an Anaconda prompt. And we will cd to our course material folder. And let's type in spark-submit spark linear regression.py and let it do its thing. So again, we're using the new ML interface that's DataFrame based. And by the way, if you're using Scala instead of Python, you'd probably be using data sets instead of data frames, just different terminology there. And there we have the results. So we have here, each result here is the predicted value followed by the actual value. And you can see that by and large, they're pretty close. I mean, it's not perfect, but the model at least did something reasonable. So that's it. That's cool. So yeah, we just did a linear regression using Spark's new ML API. Well, relatively new, or 2016. It's, several years have passed since then, but this is still kind of the way the future that they're pushing people toward. Again, RDDs still work, but the DataFrame-based API is sort of where they're concentrating their efforts these days, so it's worth understanding it. There you have it, ML in action in Spark.